Welcome to the demonstration of the PuriFlash auto sampler. Our customers were looking for ways to increase productivity with prep HPLC and flash purification, so an auto sampler was the obvious choice. The design objectives were pretty straightforward, with ease of use, optimum recovery, and high throughput topping the list. Let's get a few samples queued up, start a sequence, and then we'll get into the nuts and bolts of the auto sampler and software. I've had my morning coffee, and it's time to purify samples that I prepared yesterday afternoon. All programming can be done on the touch screen or with the keyboard and mouse. The software enables the use of column switching and different methods when setting up the queue or after it has begun. To set up the first few samples, I'll use the same method in column. I'm selecting a method, assigning a sample name, sample vial number, and injection volume, then adding it to the queue. For this run, I'm injecting once per vial selected. Other possibilities include multiple cycles on the same sample vial or multiple cycles on consecutive sample vials. These values can also be changed from within the queue. Here I'm changing the injection volume from 2 to 2.5 mils. I'm ready to start, so I begin the sequence with the start button. The gray background of the chromatogram is a visual indication that the column is equilibrating. The status changes to run in line 1 of the queue, and the collector screen shows which tube in the rack will be used to collect the first peak. The column equilibration time is shown here and can be adjusted to any time. The column was pre-equilibrated, so I'll advance the run with the start arrow. The chromatogram changes to pink when the auto sampler is active. The autosampler needle is washed at the wash station with a peristaltic pump which delivers solvent to the station and drained to waste. The syringe is purged 3 times using the same solvent as the wash station. After the wash step, the needle is moved to the vial and the syringe draws the sample to the injection module. In this case, we are using a mixture of yellow and blue food coloring, which are separated on a flash column using a step gradient from buffered water to isopropanol. After the sample has been drawn to the injection module, the needle is washed. The needle is then moved to the beaker containing carrier solvent located on the autosampler deck. The syringe draws the sample into the sample loop. You can see there is no residual sample in the tubing at the end of this step. This ensures that all of the sample has been delivered to the sample loop to obtain optimum recovery. The sample has now been injected on the column, and the method commences the gradient, detection, and collection. We now see the status of the autosampler, with the red line being the run-in process. The synoptic view displays the state of the instrument with regards to flow rate, run time, system pressure, adsorbents, and wavelengths. The flow path of the mobile phase, and whether you are collecting into tubes or accumulating waste. With purification being a dynamic environment, any parameter can be changed on the fly. The gradient can be altered by adding or deleting steps, changing the slope, or adding another solvent. It looks like the first peak has eluted, and it now appears in the first tube in the collector rack. Virtually any parameter can be changed during the run, such as collection threshold, tube collection volume, pausing the pump, or adding another mobile phase. This is especially useful if your sample precipitates and crashes out on the column. By changing solvents, you may be able to restore solubility without abandoning the entire run and ultimately recovering the sample. With this run-in process, we can retrieve archived data by opening the data folder. The report's first page shows the chromatogram and the corresponding tubes in the collector rack. The second page shows method parameters including gradient, collection, and detection, as well as peak area and plate count. Any changes to the run are also shown on the report. Back to the queue, the autosampler has advanced to the next tube in the rack with the second run-in process. The gray chromatogram showing the column being equilibrated. Now that the first run has completed, let's check the report. This is the result of the first run, and it shows 2 peaks collected into 2 tubes. So let's take a look at that rack. Here you go. Our blue and yellow dyes were separated, and we've completed successful purification. Our standard configuration is fairly simple. The autosampler is integrated with our PuriFlash instrument, which can run both prep HPLC and flash columns. This autosampler has 1 vial rack, but it can be expanded to 3 racks for up to 300 samples. The injection module has a 10 mil loop, so large sample volumes are easily managed. And with a maximum flow rate of 250 mils a minute, up to 75 millimeter ID prep HPLC columns and 2.5 kilo flash columns are easily accommodated. The software allows you to queue up samples very quickly and is quite versatile to accommodate different methods and column switching. A couple final notes on the autosampler and software. The operating system is Windows, so anything you can do on a PC, you can do on a PuriFlash. And the autosampler was designed for prep. Other models were typically modified from an analytical platform, and these analytical-based autosamplers add significant system pressure at higher flow rates, and this leads to reduced column lifetime. Thank you for joining us today, and we look forward to bringing you new products and techniques to provide you with purity, speed, and peace of mind.